let's go for question number 5 quickly. I'm not going to go into the theories in detail. So this is into set theories. You can pause the video and just give it a try. Yes, I hope you have tried the question. So let me one by one. Let me try this question. Okay, right. So question number 5, part A. Use set notation to describe the subset shaded in the Venn diagram. So we can see the shaded area, something like this. So this is a shaded area. So you can see that area belongs to the outside of the whole, the two circles. Right, the outside of the two circles, the area outside the two circles. So how are you going to write that? So first of all, we can define what is these two circles. So that is A union B, right? This is A union B. The total union is total or the sum. This symbol represents the intersection, right? So this is A union B. We get the complement of it. Complement will be the exclusion, right? Without all this area, the everything. So that is your shaded area, right? In part B, the universal set has been defined with some set of numbers. The universal set we have. What do you mean by the universal set? The total consideration we take into the account, right? In this case, these are the numbers that we consider. For some reason, these are the numbers they have given, and these are the numbers we consider. So and another set is given P set. How they have defined the set in this particular way. X, they have considered one random element X, so that element is a factor of 36. So we can rewrite this set. We can list the set according to the description they have given. So what are the factors of 36 among these numbers in the universal set, right? So I'm going to write 2 is a factor, 3 is a factor, 4 is a factor, 6 is a factor, then 9 is a factor, 12 is a factor, right? Among all these numbers from the universal set. Then Q, they have defined another set with this particular description. X is just a random element, so that random element is a multiple of 4. So multiples of 4, what do you mean by multiple of 4? 4 into 1, 4, 4 into 2, 8, all these multiples, right? Multiples of 4. So we can see the first multiple is 4, it is here, and 8, or it's over here, and 12, right? Then what about R? What is R set? It's also defined in another model, right? It's not given in words, it's given in an inequality. So X is just a number. That number is less than 6, equal or less than 6, and equal or greater than 3. So what are the numbers belongs to the description? 3 belongs to that, and 4, 5, 6. 6 or less than, 3 or greater than. So these are the elements. So first of all, we should write down all the elements, and we'll move into the Venn diagram. So first of all, we can identify the elements which are common to all these 3 sets. What is that? 4 we can see. 4 is a common number, common element for all these 3 sets, right? Do we have any other? No, right? Then we can consider P and Q. The common elements for P and Q will be what? 12, right? That's it. And Q and R, what are the commons for Q and R? Q and R, it's just 4 is already here. We don't have, right? We don't have. Then PNR, what are the commons? Commons between PR 3, 3. Oh, sorry, 3. Right, 3 is common for PNR. PNR. Then 6, 6, like this 6. That's it, right? So we can write the rest inside the region. So in P, P2 will be here, 9 will be here, right? 9, 2, and 9 gone. Then Q only 8 will be here, and R, it's going to be 5, right? So we have written down some of the numbers out of the universal set. Then the rest we can write outside the circle. So what are the numbers for that region, the outside of the circle? 2 is there, 3 is already there, 4, 5, 6 there, 7 will be here, 8 is over here, the 9, 10 we can write here, 11 we can write over here. Okay, so that's it. Then list the elements of this region. How are you going to understand, how are you going to identify this region? P intersection Q union R complement. So what is Q union R? Q union Q total with R, this region, and complement of it will be everything without that region. This is your Q union R complement, this pink color region, right? So this is pink color. And what is P? P is over here, P is here, right? The intersection will be the common region for both the regions defined. So we can see this is, I'm sorry, yeah, so we can see the common region. Let me erase this. We can see the common region in this region is a common region for this particular description. So it's going to be, they're asking to list, so I'm going to list the elements to 9. That's it, right? Then a number of elements of P union Q. What is P union Q? Let me erase this. What is P union Q? P union Q is this boundary. First of better you understand the boundary. This is your boundary, P union Q, right? So how many elements are there inside that region, inside the boundary? 1, 2, 3, 4, 5, 6, 7, right? Use set notation, Roman number 4. Use set notation to complete the statement. Something is empty. Something is empty. So this is the symbol we use, null set. This is null set, we say, or empty, right? It's 0 elements should be there. So what is that? What is the region you see being empty? This region, right? So, and how we're going to define that region using the set notation. That region is, anyway, let me erase this thing. So that region is anyway being outside P, right? Outside of P. So we can always get that viewpoint outside of P. So I'm going to write first of all P complement. So let me write that P complement. P complement is your pink color. So this is your pink color, right? P complement. And you can see this region. What is this region? This boundary is going to be the common space for R and Q, right? R and Q, the common region for R and Q. So R and Q, the common region, it's going to be the intersection, right? Okay, so that is your orange. Okay, so the region we need this region, the empty region, belongs, that is going to be a common region, that is going to be a common space for this pink color and orange color, right? So that is a common space, so we can use the intersection symbol, right? So that is a null set. So this is going to be a answer. That's it. Okay.